morning. Did you enjoy the keynotes? Welcome in this session where we are going to see how we can make building distributed systems easier with Microsoft Orleans. Who has already heard of Microsoft Orleans? Who has already used it in production? I'm Lindsey. I'm a .NET consultant at Team for Talent in Belgium. I recently became a Microsoft MVP. I also am a Pluralsight author, where I also have a course about Orleans that's a little bit over 3 hours. So if you want to know more about it after this session, check out my course. I'm a board member of VSUG, that's a .NET user group in Belgium, and I'm involved as a content group member of Tecorama in Belgium and in the Netherlands. And there's some contact information. If you have questions, feel free to contact me. Why am I doing a session about Orleans? I started at a client almost 5 years ago, where I got introduced by Orleans. They are using it. They're using it already for 6 years there in production, and I find it a really easy framework. It makes things so much easier, and I really liked it. And it is already around there for many years, from 2010, 2011 that it was introduced. But when I talk about it, a lot of people have never heard about it. And I think it's a shame, because I think it's a hidden gem in the .NET ecosystem. For the agenda of today, I'm first going to see what are distributed systems and what makes it so hard to build them. And then we're going to see how Microsoft Orleans can make your life as a developer easier. What is a distributed system? A distributed system is a system that runs on multiple computers. They need to connect with each other, they talk to each other. And they have, because they are running on multiple servers, they have the advantage of scalability, fault tolerance, but that also makes it harder to build them. So one of the most basic distributed systems is, I think, a multi-tier application where you have a presentation layer, the user interface, the mobile application, the website, where the user that uses. The request goes to a server. It needs to get a round trip to a database, and it goes back to the user. Those components are usually on multiple servers, and they need to communicate with each other. When you have one user that uses it, or a few users, you don't need to think about scaling. It's really straightforward. But when you have multiple users, and more users are starting using your application, you need to think about what do you need to scale, how are you going to load balance the load between the servers, how are you going to make sure that there are no latencies, that the database is not going to be a bottleneck anymore. So you can add caching layers, but then you start adding more and more components that makes it really harder to maintain everything. So when you think about building distributed systems, there are a lot of things you need to think about. First thing is scalability. What components need to be scaled? When do they need to scale? How are you going to do the load balancing between the components? When are they going to need to scale? Do they need to be scaled every time or only when there are peaks? And how are you going to do that? The data management, if you have multiple servers that are connecting to the same database, how are you going to make sure that all the data is consistent about every part of your application? The concurrency. When you have multiple servers that connect to the same database, how are you going to avoid race conditions that the data is consistent, that then fault tolerance. But how is your application going to react when one of the servers is going down? Is the whole application going to fail? Is only a part of the application going to fail? How are you going to handle that? And the last thing, when your application is under high load, how you're going to make sure that everything is running smoothly, that you keep having fast response times, especially when every request is going to a database. Yeah, database transactions are slow, but how are you going to keep fast response times when under high load? So when you think about building distributed systems, it can be hard. But Microsoft Orleans can make it really easier. What is Microsoft Orleans? It's a framework developed by Microsoft in 2010, 2011. And it's specifically built to build distributed systems. It simplifies the development process. It abstracts away all those complexities of building distributed applications so that you, as a developer, can focus on what you need to do, building the logic. And because it abstracts away all those complexities, so you don't need to think a lot about scalability, fault tolerance, and your whole application is a stateful application that is based on the actor model. The actor model, it's also not new. It's first described as a research project at MIT in 1973, so that's already more than 50 years ago, by Hewitt, Bishop, and Steiger. They developed the actor model, which is a theoretical framework for concurrent applications. Their basic unit was the actor that has identity and behavior. Those actors, they receive messages, they can send messages to each other, and they can create other actors. And each actor is its own entity. Microsoft Orleans is based on the actor model, but it's not quite the same. It has a lot of similarities, but here and there are things that are different. First, with the actor model that was first described, you need to create the actors yourself. With Microsoft Orleans, they virtually always exist. They are automatically instantiated by the framework, so when you send a message to one of the actors, which are in Orleans also not called actors but grains, the grain will automatically be there. So you don't need to know if a grain already exists or if you need to create one, the framework will handle that for you. Also, you don't need to know the location of a grain. When you have multiple servers, you don't need to know on which server which grains are running. And it can automatically scale out. If you add a server to an Orleans application, it will automatically handle the load. So here you have the grains, or they are here shown as little dots. In each grain is an entity. Let's say you're building an application to sell tickets for concerts, then each grain can be a specific ticket, a specific concert, or a user that will buy a ticket. All those grains that live in silos. Silos you can see as a server. They are the hosts of the grain, and they manage the lifetime of all the grains. If you send a message to a grain, one silo will receive that message and will see if that grain exists on that server. If it doesn't exist on that server, it checks if it is running on another silo, and it will pass the message to that grain if it's already there. If it's not there, then the silos, they work together in a cluster, and it's a cluster that handles the load balancing between the different silos. So when a grain is not active yet, the cluster will select a silo on which the grain will get activated. And it's also the responsibility of the server, of the cluster, that when one server goes down, the grains that are still active are distributed between the different running silos. A little sidestep before I show the first demo. I've built my demo with .NET Aspire because it makes it easier to build it. And yeah, .NET Aspire is a powerful for tools, templates, and packages for building distributed applications. So it's a good combination with Microsoft Orleans. And it improves the developer experience. And when I created the demo for this talk, I started using it because I created it on my desktop computer, and I just had to install Docker on my laptop, and it started running quite easily. And I don't need the Wi-Fi, because Wi-Fi at conferences is not always that good. So I have here two folders, one for the Aspire stuff, and then a folder for Orleans for all the projects of Orleans. When we go to the app host of the Aspire project, you define all the resources that you are using. So I'm using the Azure storage, and I run it as an emulator, so I don't need to actually have a connection to Azure. I'm using table storage and blob storage for the definition of the clustering and for the states of the grains. I will come back to that later. It's in that table for the clustering that the framework keeps everything, that which servers are active, which servers are maybe not active anymore, so they know which servers they can activate grains on. Then you get the definition for the Orleans project. Just add Orleans with a cluster and a service ID. This cluster and service ID you need so that different components that uses Orleans, so the silo projects and the client projects, so the project that will talk to the cluster, can find each other. Then you define the clustering, the storage, and the memory stream that I use. And like you see here, everything is just plug and play. You can just add what you need to the project. Then I have here the definition for the silo project, where we add a reference to the Orleans reference that we have defined above. And we wait for the storage, the clustering that is up and running before we start our silo, so that every resources are up and running. And I will run the silo with 5 replications. So this project will be started five times. So like you have 5 servers running with the application. And then I have a client application where I can show you which grains are running where. And to define a client application, you just add a reference to Orleans with the extension as client, so that it knows that it's not a server, but a client. And I also have a project to add some simulations, like creating concerts, buying tickets, creating customers, and so on. So in the Orleans applications, we have 2 projects. One is for the definitions of the grains. In that project, you only need to add the package Microsoft.Orleans.sdk. And the same is for the grains application. But here, because I have also streaming implemented in my in some of the grains, I also needed the streaming package and the Orleans runtime package. Then the silo project. Here you need a few packages for Aspire. And for Orleans, you just add the packages that you need in your application. The one that you always need is the Orleans server package. And in a client application, it's just the same. You need the client package, and then you add the packages for the features of Orleans that you are adding to your application. So now we have seen the structure of an Orleans project. The basic building blocks is a grain. A grain is just a regular .NET object. It's just like you write other applications in .NET. But all those grains are single-threaded, and they are by default asynchronous. So they pass messages asynchronously, so they are processed one by one. And because they are processed one by one, you don't get race conditions. Because when multiple components are talking to the same grain, the messages are processed in the order that the grain will receive it. A grain, it has an identity, so that the grain can be found on the different silos. It has behavior, and it can have state. When we first take a look at identity, you define a grain as an interface, and you implement one of the Orleans interfaces. Here is the iGrain with integer key. Then you say this interface will be an Orleans grain with an integer key. The identity of this iConsort grain will be consort, because it's a consort grain, and with an integer identity, for example, 7. So the whole identity of that grain will be consort/7. You have different options to implement. For example, I have the integer key, but you can also use a GUID key, a string key, often a combination of a GUID and a string, and an integer and a string. Sometimes you need grains that are singleton grains. You can do that, and by convention, you then implement the iGrain with GUID key. So you have a GUID key, and you give it an empty GUID key. So then you know in every part of the application, if a grain has a GUID empty key, it will be a singleton grain. Like I said, the cluster is responsible for, and the silo are responsible for the life cycle of a grain. It checks if it is already active on one of the silos. After, by default, 2 hours, every grain will get deactivated. And if it has persisted state, that is persisted, but when it gets activated again, that state will be loaded again in memory. We know what the identity is. Let's move on to the behavior. The behavior, it's the logic that will be triggered when a grain receives a message. And it's just like any other .NET application. When you write interfaces, you get contracts of the methods that can get invoked. And the state. A a grain can have state in memory and or persisted state. And persisted state is also in memory when the grain is active. How you do your add state? When you want only in memory state, you just add fields to your implementations of the grains. So here, the concert grain, it inherits the grain base class and the interface iConcert grain. I have here a private list of strings from ticket IDs. This state will only be there in memory. When the grain gets deactivated, this data will get lost. If you want to get it persisted and will be there when the grain will get activated again, you need to wrap it in an iPersisted state object. Then this data will get reloaded again when the grain gets activated, but you still need to write it yourself to the storage. That won't get done automatically. So when a grain gets activated, the onActivate async method will be called to get the persisted state back in memory. You can override it and add extra logic. For example, when you want to add logging of when a grain gets activated. But you need to be careful with which logic you add to the onActivate async method, because when something fails in that method, your grain can't get activated, and the messages it's received can't be processed. Also, on the deactivating side, you can override on the deactivate async method. But here you need to be careful that you don't do logic like, for example, writing your data to a storage, because this method is not always executed. For example, when a silo fails, and it's not guaranteed that the onActivate async method will be executed when the silo is not shut down gracefully. So you don't add logic for things that always needs to be done. So when we take a look at grains, I have here a few definitions of grains. Like, for example, the iConcert grain, is what I showed in the slides, has an I grain with integer key. So the key will be concert / an integer. And the user grain, it has a GUID key. So the identity of such a grain will be user / and a GUID key. And when we take a look at the concert grain, for example, I here have a few state objects that are persisted. So they are wrapped in an iPersistent state object. And in the constructor of such a grain, you also need to inject that persisted and those persisted objects need an attribute, persistent state, with the name of the storage where you will store it and the storage name itself. And for example, here when you save a concert, you set the state to the concert that you want to save, and you need to write it with write state async methods to the storage. Okay, we have now our grains. We know how we can define them, but how can we communicate with each other? Because with the behavior, we can trigger the methods, but how are we going to trigger that? Well, there are actually two ways of communication. The first one is from outside the cluster. With that, we use the iCluster client. When you remember, when we set up the client, we did it with reference Orleans.s client. When the host is built, a connection to the cluster will be opened, and actually the iCluster client that opens that connection. And when we inject that iCluster client in a service where we want a connection to the Orleans server, it will be available. Then in a method, you first get a reference to the grain. So you ask for the cluster, get a grain of type iConsort grain with this ID. And on this reference to the grain, you can then invoke the methods defined in the interface. For every object that is passed to a method or is a return type, it needs to be serialized. Orleans uses its own serializer, which is high performant, but you need to add attribute generate serializer, and on every field you need to add an ID. That's the way how we can communicate from outside the cluster. Between grains, you can also communicate, and then you use the iGrain factory. With that, it's actually the same as with the iCluster client. The iCluster client implements that iGrain factory, but that has only the extra functionality that it can get a communication into a cluster. And to use it is basically the same. You inject the iGrain factory, you get a reference just the same way, but with the iGrain factory, and then you invoke a message to unlock grain. So when we go to that new concert simulator, you see that I injected the iCluster client, and I added some fake data with bogus, and then here I get a reference to that concert grain with that ID, and I save the concert. Then in the user grain, users can invoke a message to buy a ticket. Then we get a reference with the iGrain factory to a concert, and then we can invoke the method to buy a ticket. And when we now run that application, it takes a while. The Docker is running.
The demo demons are working against you.
No, the silos are the containers, and every grain is an entity of your application. So the Aspire dashboard is starting up, and you see that all the resources are waiting until the storage is up and running. When you go to that my client application, you can see here that concerts are getting created, that tickets are getting sold, and customers are getting created. In this view, I have all the different silos. I started it with 5 replicas, so I have 5 silos, and they are all active, and you see that the load is distributed evenly among the customers and the ticket grains. When I now stop one of the silos, the demo is not working with me. So when I stop, let's try that again. And now, in a moment, normally one of the silos will change its status. Yeah. The first one is that. And you see that on the other silos, still tickets are getting sold, so the count is still getting up.
How do you compare this audience with durable functions measure? There is some sort of similarity in between.
I haven't used durable functions, so I don't know. Yeah, this what I touched is also only the basics of Orleans. Orleans have a lot of other features. So you have timers and reminders, so you can trigger behavior on a grain on a regular basis. The difference between a timer and a reminder is that timers are only in memory, so when a grain gets deactivated, it won't be triggered again. Reminders are persisted, and when a reminder is triggered on a grain, it will also get automatically reactivated again. Then you have observers, so you can send from one grain, send a message that other grains will asynchronously pick up. The same with streams. And you can also have transactions, so that when you, now in my demo, I did buy the tickets, but I did a few logic in there. But when one thing fails, some things are already done, but other things are not. You can do the whole process in transactions. I have a little bit of time, I think, for so in this user grain, when I save a customer, I send via a stream that a customer is created. To implement this, I need a stream provider. That was also defined on in Aspire on the Orleans resource. I have here with memory streaming named shop, and that is also a blob storage. Then you can create a specific stream on that stream provider. I here call it a new customer because I have a new customer ID, and the GUID to the grain that will receive it. And the grain that will receive it is a shop grain where I have all the customers listed. So, like I told, when you have a singleton grain, you use the GUID empty key by convention. Then you create a stream and you send the message that you want to send with the onNextAsync method. Then in the shop grain, I have an implicit stream subscription to that shop stream. In the onActivateAsync method, I also get a reference to that same stream ID, and I subscribe to the messages on this. When that grain receives a message from the stream and it's not activated, it will get activated, so that it will always receive the messages sent to it with a stream. And here I just log that a new customer was created, and I update the customers list. And I did the same when I created new concerts. Orleans is really powerful. It's just plug and play. You can choose which storage you use. You can add features by adding extra packages. But is it for every project? It is really suitable for projects that have a lot of real-time data, that you need to show real-time data for example, in multiplayer games, also in event-driven architecture, or when you would otherwise write microservices. It is only suitable if you have a lot of entities. So not when you have a few entities that have large states, then it's not that suitable. Also, when you need to run your application on multiple servers, when you need low downtimes, because it has no downtime when one of the servers gets down, and you need fast response times. Because the state is already in memory in every grain, you don't need a round trip to a database with every request. The data is already there in memory. And when you have, it's also very suitable when you have grains that will have a long lifetime. For example, your shop grain with all the customers and the concerts, or a concert grain, but you also have grains that have a short lifetime. For example, a grain, the ticket will only be needed on the time that you buy it, and it's not a long time that it needs to be in memory. And then when the concert is there, that's when you need to check the grains, check the tickets. Then you need to reactivate all that grains. When it is not suitable, when you have compute-intensive logic that you need to do in a lot of grains, it's a really when you have fast, not compute-intensive tasks, then it is suitable. But when you have long-running tasks, then Orleans is not that good. Also, it's not that good when grains need to talk continuously with each other. And when you have grains when all your grains have a large state, because all the state is in memory, it is, you only have the resources that you have. If all the grains have a lot of state, you will need more servers. Are there any questions?
How do you, I'm trying to map it out in my mind. So how do you compare this actor model to a complex microservice architecture? Is a silo a microservice or?
No, for a microservice, you have every part of your application is a different, it has a different project. Here you have one project where all your different components are running on all the same servers. So it's not that one server is for, for example, here all the concerts, and one is for all the tickets. It will all spread out about all the servers.
Some sort of microservice.
Yeah, sometimes it's called a grain, sometimes called a nano service.
Nano service. Yeah.
So every grain is a different entity.
Is it possible to make a tree-like relationship between grains?
No, grains have their own state, and they can't get access to the state of another grain. So, yeah. Yeah, I know in akka.net you have a tree that's not in Orleans.
How is the maintenance of the storage managed? Storage, is it self-managing?
You
blob storage?
Yeah.
The maintenance, the growing and the shrinking?
Yeah, that's how you set up your blob storage. Like I now use blob storage, but you can use any kind of, for a state, you can also use Redis or some other things. It's just how you set up that. Yeah, we does, in the project I'm working on, we use a SQL Server for all of the states to manage it. And yeah, it's just the database, so you can use everything.
Is it easy to set up projections across multiple grains when you need to do read models?
I didn't understand.
Can you create projections of states across multiple grains? Because you probably need to build some read models or some insights into multiple data from multiple grains.
I don't really understand, but I think I'm running over time. But you can come, if you have other questions, I'm here all day, so you come see me and I will try to answer all your your questions.
Final question. Why isn't this so popular?
I don't know. I really like working with it. Also, when juniors start on our project, they are immediately up and running with everything. They understand it quite easily. We don't have that much problems with, load balancing and all those things. So I don't know why it's not used more. Thank you. And,